building, room 5101. So now it's my pleasure today to introduce Dr. John Samet, who asked me to keep this short, so I will shorten it as much as I can. But he is our former dean of the Colorado School of Public Health and has really made his career as an expert in environmental and occupational health, the focus on inhaled pollutants, and has really been a national and international figure within that field, has chaired many different committees looking at this, discussing things at the World Health Organization, with the EPA, and has been the editor of the Surgeon General Report on Smoking and Health for a very long period of time, has been a member elected to the National Academy of Medicine, the National Academy of Sciences, and has received more awards than I will mention in the goal to keep it short. But he really has published more than 400 peer-reviewed articles in this field and contributed to more than 200 books. And so we are excited that we were able to have him come to Grand Rounds today. So please join me in welcoming him, who will be presenting From Tragedy to Hope, the 80th anniversary of the atomic bombings.
Great, thank you, and it's nice to be here, and thank you for the invitation. I've been to enough Department of Medicine Grand Rounds to know this will not be the usual one. I gave my first one when I started my career at the University of New Mexico in 1978, and New Mexico sort of figures in how I ended up here talking to you today. In terms of learning objectives, here they are. I'm going to tell you the story of the research on the atomic bomb survivors, why it's so important. And it's hard not to talk about this without talking about everything else that goes along with the atomic bombings and their amazingly germane relevance to what is happening today. I have no conflicts. I have my own biases about things nuclear, and I will probably expose some of them while I'm speaking with you. The talk that I'm giving grew out of presentations I made in June in Hiroshima and Nagasaki. This was the important year, the 80th commemoration of the bombings. It's also the 50th anniversary year of the Radiation Effects Research Foundation, which I'll talk about, which continues the studies of the survivors that began with the Atomic Bomb Casualty Commission. Now, in terms of the introduction that you need, why I'm here talking about this, a little bit of it has to do with the serendipity of careers and how things happened. I ended up finishing my residency at the University of New Mexico after being in the Army in the early 70s. And New Mexico, as I think everyone knows, has been a critical venue for so many things nuclear. Los Alamos, who's seen Oppenheimer? Probably a lot of you, yeah. Los Alamos, White Sands, Sandia National Laboratories, and more, and uranium mining, which is how I ended up involved with the radiation stories. So that 1980 is me about to go underground in a uranium mine at Ambrosia Lake, New Mexico, which is sort of 100 miles northwest of Albuquerque. We had started a study, a cohort study, a follow-up study of New Mexico's underground uranium miners that still goes on. The table there is the report from the first paper, and the men experienced a fourfold increased risk of lung cancer compared to expectations. We're still following this group, and unfortunately, that excess holds. But doing that work drew me into this whole area of radiation risk assessment. How do we assess the risks of radiation? In particular, I got involved in the radon story because uranium miners inhale radon and its decay products and produce these reports from national academies, the biological effects of ionizing radiation reports. And we'll come to how atomic bomb survivors figure into those. The green one still stands as how we look at the risks of radon for workers, but more generally for indoor environments. And they continue to drive EPA guidance. This work on radiation risks led me to become involved with the Radiation Effects Research Foundation going back almost 30 years ago. So there's a picture of the board of directors, of which I was a member for, I think, 6 or 7 or 8 years. And then more recently, they reorganized RERF as a counselor. There are 8 of us, 4 from the US, 4 from Japan, who are really charged with administrative oversight of the foundation. So this is also a Colorado story, and a few things you ought to know about. One is if you look at this, here it is. If you look up here, the density of uranium mining, the Colorado Plateau was a critical starting point for the underground uranium industry, actually building on earlier mining of vanadium and radium. This is Charlie Steen, who made the first big strike, struck it rich, spent a lot of money, and ended up bankrupt. If you've been to Moab, you could go to the Sunset Restaurant, which was his home. It's a great spot for looking at the sunset. Rocky Flats, I'll say no more. Uravan, Colorado, run by Union Carbide, a Superfund site, evacuated eventually. Gino Sacamano, anybody know of Gino? So Gino invented sputum cytology. He was the pathologist in Grand Junction, the only pathologist in that part of the world, and he developed the techniques that were used to separate the cells from the mucus. The answer turned out to be he took a sample of sputum home at lunch, put it in the Waring blender, and it worked. So there you go. And then a quick quiz question. How many nuclear explosions have there been in Colorado? You could say 0. Anybody vote for 0? I'm giving you a leading question, right? Because the answer is more than 0. It's actually 4. And this was part of Operation Plowshare and efforts to extract gas from underground reservoirs. One of these was Project Rulison. So let me go on then with the story. And I think you know what happened in 1945, August 6th and August 9th, Hiroshima and then Nagasaki. This is the so-called atomic dome still standing, and I'll show you some picture of it later on. The number of deaths, big, obviously counted with estimated with a great deal of inaccuracy, but there are some tragic figures. Now, by 1945, when the bombs were dropped, the fact that radiation had adverse consequences was known. And I'm just going to highlight. And if you think about it, 1945 was only 50 years after Röntgen described X-rays. And this is the famous picture he took of his wife's hand, not worried about radiation exposure for sure, and her wedding ring. And then the Curies, Madame Curie died of aplastic anemia, most certainly from her radiation exposure. The radium dial painters, these were women who painted radium dials with brushes that they tipped in their lips to get a fine point and ingested the radium, which caused cancer through mechanisms I won't go into, but eventually involving radon production. And then this question of genetic abnormalities. 1927, Muller described mutations in a fruit fly model. So much was known heading up to 1945. The story of what happened after the bombings is fascinating. I'll give you a reading list later, but this book, The Atomic Doctors, describes the immediate aftermath. Dr. Nagai, who was a radiologist in Nagasaki, actually went out and began to look at populations and describe the immediate horrid consequences of the blasts. The US sent 3 different groups, and critical to those were these 3 physicians, Nolan, Hempelman, and Warren. The story of this book is interesting because the author is a historian, James Nolan Jr., who found his grandfather's papers that led to the book. So initially, and this is again well described, the US tried to attribute what was happening in Hiroshima and Nagasaki after the bombs to the blast and to fire, downplaying the risk of radiation, the fact that thousands were suffering from acute radiation sickness. And that eventually was all laid out. Nagai wrote this book, The Bells of Nagasaki, a short book that describes what he did as a physician in the aftermath, some of the later survey work, and what happened to the people who worked with him, the nurses, other physicians, medical students. And again, a short book worth a read. So the more formal studies began in 1946. This is a letter from Secretary of the Navy Forrestal to Truman, signed by Truman, that led to the Atomic Bomb Casualty Commission, with the National Academy of Sciences charged with doing the studies, which they had the lead on for some decades. This is where the work is being done in Hiroshima, which is the main site. This is the building. And just to show you the problem, here is the way it looks. The original Quonset huts are basically still in use as a facility. And we finally have been able to raise the money from the Japanese government to move the foundation. Early on, there was a wave of studies. And reading those studies, it's fascinating to see how many important figures in medicine were involved in them. For example, Wintrobe and others around hematological problems. Pregnancy outcomes, a very important part of the story. Cataracts from direct radiation injury to the eye. Leukemia. Unexpectedly, within 2 to 3 years after the bombings, there was a wave of acute leukemias. And this came and disappeared, as you'll see, and then lots of descriptive stuff like blood abnormalities. Now, the Atomic Bomb Casualty Commission made its way. Think about starting research in the aftermath of this disaster, the problem of pulling people in to do research when in fact they were the victims of the bombings, the US leading the research. It was a difficult start. In 1955, there's a so-called Francis Report. Now, what you want to know about Francis, among other things, is he led the field trials of the polio, the Salk vaccine. In 1955, they were reported, the high efficacy of the Salk vaccine against polio. So we also have Francis's impact at the Atomic Bomb Casualty Commission. What he said is that the Atomic Bomb Casualty Commission needed to get its act together and that they should get organized. And he proposed that different populations be enrolled, some closer to the hypocenter and some further away as control. And with that, the current structure of RERF was, the RERF cohorts was established. He also commented on the importance of what was going on for science to learn about the mechanisms. And that's a theme I'll return to when I talk about where things may go in the future. There was a transition from the Atomic Bomb Casualty Commission to the Radiation Effects Research Foundation 50 years ago. The ABCC had developed a bad name with the survivors, in part because it did research, but it did not really provide treatment. So there was a gap between expectations and needs and what the Atomic Bomb Casualty Commission was doing. So this was a new start for this research. And here from its articles of incorporation, again, this theme that comes up over and over again from RERF and from the survivors, contributing to maintenance of the health and welfare of the atomic bomb survivors and to enhancement of the health of all humankind. So the survivors are making a contribution to all of us. So this is the structure of the cohorts. These cohorts are based in both Hiroshima and Nagasaki. There's the lifespan study, which is primarily a study of mortality, 120,000 survivors. There's a group who are exposed during gestation. There's a group who come in for more detailed clinical exams. That's the adult health study. Some of those exposed in utero come in, and there's a study of 77,000 offspring of the survivors. This is a very tricky territory. The survivors are referred to as the hibakusha, the baksha, and there has been stigma associated with being in that group, in part because of concerns that perhaps genetic material is damaged and mutations and disabilities will be passed to children. But this is the basic structure. And for each participant, there's been a detailed assessment of the dose of radiation at the time of the blast. And this has been done through sort of successively more sophisticated systems. What goes into this? Where was the person at the blast? What was their position? This is all from detailed interviews conducted long ago. Now, actually, there is a conversion of the dose into organ doses. So risks are being looked at, say, for cancer of the liver in relationship to the estimated dose of radiation to the liver. So this is a very sophisticated resource for research on the health consequences of radiation. So what's been learned in 80 years? Think about an epidemiological study, a study going on roughly 80 years. There aren't many. Framingham continues and is up to, I think, second generation of Framingham offspring. But this is I think, unique resource among the world's epidemiological studies. Here's our cohorts. And then here is the rate of cancers over time. Here's that burst of acute leukemias that went away. Here is the rise of everything else, solid cancers referred to, and then a host of other factors that have been looked at in the survivors. So cancer, those exposed in utero, and the children, with emphasis on possible cross-generational transmission of mutations. An important area that I'll come back to. So for cancer, the approach is pretty straightforward, tracking the occurrence of cancers and lining up the rate of cancer occurrence in relationship to dose. And that derives these risk estimates, which is shown here. So this is the extra risk of getting a cancer, this graph for men, colon, bladder, prostate, and so on, in relationship to exposure. And it's lined up with a unit of gray, okay, a measure of ionizing radiation exposure. So this kind of information, as I'll show you later, is how we estimate the risks of radiation. So very, very valuable, clear increases for many sites. And then there are these questions, how do the risks vary with other factors? So for example, does it matter at what age the exposure took place? And the answer is it does. The younger the age of exposure, the higher the risk. For breast cancer, it turns out there's a critical window around puberty when the breast tissue appears to be particularly susceptible to radiation. So again, we've learned a lot from this sort of analysis of cancer. And sort of putting it all together, here's these overall extra risk estimates for men and women together, and then all these different things that make these risks vary a bit. So for lung cancer, question, does risk depend on whether you smoke or not? A very important question. Are smokers in general at greater risk for lung cancer? And other factors. So RARF has produced this massive body of information that underlies much of how we approach the risks of radiation. Reproductive outcomes. When the studies started, there was a great deal of emphasis on likely adverse reproductive outcomes including from the work of Muller, the possibility of transgeneration transmission of passage of genetic mutations. This paper, published in 1981, comes from some of the principles, or actually a whole series of reports coming earlier, mostly saying that we don't see anything. Okay, so here's the highly exposed population, one that we can learn from. So this one says mostly we don't see anything. This is yet another update saying that. And then the most recent paper, which I work with the investigators closely, the first author went back and went through all the papers from 1948 to 1954, looking at the original records, correcting things. And here are different adverse effects. Here's increasing paternal dose and maternal dose of radiation. And there's a hint for some of these that they are going up, okay, a hint. And again, here's the problem of epidemiological studies. Sometimes they're not big enough, but there is no bigger, nor do we want another one. So this is sort of where this evidence stands. And I'll come on now to how we're taking a more sophisticated look at this. So here is the kind of one hand, other hand thing you write at the end of a paper when you're not sure exactly what you found. Cataract. Cataract is so-called non-stochastic effect. That is, the severity of the response depends on the exposure and the dose. The findings from RERF have been very important for guiding international protection for radiation protection against cataract. And there are a number of occupational groups, for example, who are at risk. So again, here is the risk for developing cataracts. It's actually of a particular type and radiation exposure. One of the surprises, and this was published in a paper about 25 years ago now, was that just longevity in general dropped as radiation dose increased. And of course, with cardiovascular disease as the major killer, that was looked at, and in fact, in the survivors, that is over here, rising risk of cardiovascular events with increasing radiation dose. And over here is the increasing loss of life expectancy with increasing radiation dose. So this remains under investigation. There's a number of interesting reasons why cardiovascular disease might be worse related to cell proliferation related to radiation in the blood vessels. The F1 generation, critical. And again, so far, not a hint of decreased survival or excess disease risks in these 70,000 plus survivors. The one look at this question of transgenerational passage of mutations was taken in a study done at Chernobyl. This is the children of the cleanup workers at Chernobyl, taking a look at this, a paper published in Science a couple of years ago. Did not find anything, but too small really to take enough statistically significant, powerful look at this. So I've passed through 80 years of research very, very quickly. And I'm going to go on to this question of how are these studies used? So over time, RERF has published over 2,000 papers. A little bit hard actually to get a count, but a lot. And you can see their publications over time and the citation frequency. So there are about 70,000 plus citations of RERF work. It's probably not the citations in the peer-reviewed literature that are so important, but how the work from RERF is actually used. This is the themes of the papers that are citing RERF data. And I'll just highlight that so much, and of course, not surprisingly, has to do with oncology, radiation, radiology, nuclear medicine, public health, and so on, but with broad applicability. RERF does have laboratories and carries out substantial radiation biology. So how are these used? So limiting occupational exposures to radiation workers, medical personnel, and others, developing evidence-based guidelines and regulations, estimating the risk of medical radiation, which has grown and become the major source of radiation for the population, compensation of cancers caused by radiation exposures, and addressing special populations such as aircraft flight crew personnel and astronauts. I just took on chairing a committee at the National Academies of Sciences that is charged with looking at radiation exposures of aircraft flight crews, perhaps of interest to some of us in academia who spend as much time as on airplanes as in our offices. We're exposed in airplanes to galactic cosmic radiation. Did you know that? Now you do. And we're exposed to that in Denver, of course, more than at sea level because of our altitude. So we're charged with looking at this issue. It's really important for the astronauts. And there's been a lot of work on radiation exposure of astronauts. So if we're truly going to Mars, and it's multiple years getting there and multiple years coming back, what are the risks and what is the radiation exposure to galactic cosmic radiation? There's been a lot of work on that. This is a model that is used to estimate those risks down here at the bottom, astronaut cancer risk. The starting point are the estimates coming from the lifespan study, 120,000 folks at the Radiation Effects Research Foundation. So broad applicability, and then this very special place of radiation exposure of the astronauts. So in terms of assessing risks, this is a figure with the table underneath showing the exact amounts of where US population radiation exposure comes from on average. So radon used to be the dominant contributor, naturally occurring, but now medicine has taken over with all the blue as we image more and more and more. So risk assessment gets at the question of what are the risks of these various exposures to the population, to patients? And so that's where we go with using this technique. So the first question is, does whatever it is we're looking at pose a hazard? In the case of radiation, the answer is yes, causes multiple cancers. The next question is, what are we exposed to and how much? And again, we have this, or we have work on specific occupational groups, cohorts, like the uranium miners. And then this question of how much risk, that comes from the risk estimates that I showed you. And that's all put together in a big step that says, here's how much cancer, whatever it is caused by radiation. And that leads to papers like this one, projecting lifetime cancer risks from current CT imaging. Okay, this is a paper published about a year ago that caused some controversy because of the numbers. It follows exactly the paradigm that I said. And this is, again, sort of a public health assessment. Are we over imaging? What are the consequences? So there are many users of RERF data. This is sort of the alphabet soup of agencies that rely on these estimates. Some of them are critical globally, the ICRP, the International Commission on Radiological Protection, the United Nations reports, the National Academies, and others. So these estimates underpin a lot of our work on radiation safety. So I'm going to turn to the future at RERF. And as I mentioned, a critical step finally achieved was getting approximately 70 or 80 million US dollars from the Japanese government, the Ministry of Health, Labor, and Welfare, to build a new building, which is now going up on the grounds of the University of Hiroshima. And there it is. There are some incredible challenges. RERF has accumulated about 2 million biosamples, blood, tissue, other materials. they have to be moved, which represents a challenge. They have paper records dating back to the late 40s, 1950s that they seem reluctant to scan and part with. So all that has to somehow be moved into this building once complete in about 2 years. They're moving to a new model for doing science and trying to reach out to collaborate, to bring in the many scientific disciplines that could augment the research, that could collaborate and use new science to do things, all the while maintaining contact with the atomic bomb survivors, the children, and the survivor organizations. So part of the challenge here are the ethical, legal, societal issues, ELSI so-called. They're very sensitive to this. And they worked for 3 or 4 years with survivor groups, culminating in a meeting held about a year ago that explored things. There are lots of questions about return of materials when whole genome sequencing is done on everyone, to the participants and to the children. At this point, 15 to 20% of the survivors are still alive. Remember, longevity in Japan is far longer than here, with women living, I think, median life expectancy about 85 at this point, men somewhat lower. So they work through these issues. And I will say in general, the response of the survivor groups has been, we're in. This is how we're going to make our contribution to humankind, if you will. But a lot of work and thought has gone into this on the part of RERF, but joining with other ethicists and others from Japan and beyond. And there are numerous scientific questions remaining. The sort of trigger word for controversy in the area of radiation is low-dose radiation, however that might be defined. It's a bit political, and in part because to estimate the risks, we use models of risk that start somewhere up here, go down to no exposure at all, without a break, without a threshold, so-called linear no threshold theory, which has become, like too many things, politicized. And I won't go into it unless somebody wants to know a little bit more, but this is a report from the National Academies a couple of years ago setting out an agenda for low-dose research, and in part specifying all these new tools that we have to really dig in deeper mechanistically so that we can decide what is the right curve for dose response, and are there thresholds? Are there reason to think about thresholds? So again, for example, using the epigenome, doing very detailed sequencing to look at mutations and so on. And this is just one example of the opportunity for research across the translational spectrum. Laboratory work on clonal hematopoiesis, the idea that some cells are transformed and then they multiply and cause disease. This from animal models at RERF, and this an exploration of this phenomenon in Chernobyl family is certainly to be repeated in the survivors. And then this transgenerational question now being addressed by a trio study, mother, father, offspring, whole genome sequencing, looking at whether there are identifiable mutations that have been transmitted. Again, this is a difficult area to move into. Statistical power is going to be a huge issue. And I just put this up, this is just published, because this question about the consequences of radiation exposure during pregnancy persists, and the trio study will be an important step forward in answering that. So in closing, I want to talk about the survivors and their contributions and what they have offered to the world. Sadly, their experience remains so relevant to current days. We have somewhere around 12,000 nuclear weapons extant in the world. It's actually, the number's down from, I think, the peak of 50,000 before there was arms reduction. Of course, multiple countries have these weapons, and multiple of these countries are currently involved in conflicts of one sort or another, as everyone knows. And the sort of nuclear saber rattling that we hear going on is quite terrifying, in fact. And with this form of warfare launched, how it ends is certainly not clear. We had some movement towards reduction, obviously. And then, of course, nuclear power, with a lot of discussion about future generations of reactors and what are the potential risks to the population. I went to, one of the problems in my mind is the end of the fuel cycle. What happens to the fuel rods? And they're parked besides nuclear power plants. You may remember at Chernobyl, they ran it, the cooling water stopped and they had meltdowns, the fuel rods. I was at Chernobyl probably 14, 15 years ago, and they had just built a new containment facility for the fuel rods. And we had an interesting conversation about what was going to happen to them. And we asked how long, what was the life of the building? And they said 50 years, because by then we'll know what to do with it. Okay, which of course is probably what people were saying 50 years ago as we began to stack up spent fuel rods beside our nuclear power plant. So still relevant, radiation exposure continues. So just to wind up, President Obama visited the Hiroshima, this is the Peace Park in 2016. His words, why do we come to this place, to Hiroshima? We come to ponder a terrible force unleashed in a not so distant past. We come to mourn the dead, including over 100,000 in Japanese men, women, and children, thousands of Koreans. There are actually many Koreans present. Some Americans, their souls speak to us. They ask us to look inward, to take stock of who we are and what we might become. The survivors, the survivor organization, the Nihon Hideyanko, won the 2024 Nobel Peace Prize. What the survivors have done is taken a strong stand on the impossibility, the unacceptability of further nuclear war. And this is their citation from the Nobel Prize Committee when they won. When I spoke in Hiroshima, the survivor who spoke with me, I gave a wonderful talk, and part of it was a video about sort of his trip to Stockholm to receive the Nobel Prize. And it was just sort of a really nice personal vignette about his story of getting there and his story of the survivors being acknowledged in this fashion. This is the Peace Park. This is the atomic dome seen through this arch. This is the cenotaph where the names of those killed by the bombs are written. This is the Peace Park in Nagasaki. This is here. Hiroshima, when I'm there, I always make a point of going to the Peace Park and watching. It's interesting, the Japanese, as they cross the cenotaph, inevitably stop and bow, which is their acknowledgement of what happened and what went on. So this, as you saw in the earlier picture, was the only structure standing near the hypocenter. It was quite close to the hypocenter after the blast. Remember, these bombs were actually exploded in the air above the cities. So this is the writing on the cenotaph. Let all the souls here rest in peace, for we shall not repeat the evil. So that's the last sentence that I want to say about this, because I think it speaks so powerfully for itself. I'm going to give you some reading, if you want some, with help from Sharon Pine, in thoracic oncology, who is editor-in-chief of Carcinogenesis. She sparked a review issue on RERF and some other aspects of radiation. I have a piece there with a colleague on the uranium miners. So if you're looking for a way to learn more, go there. Over here, you'll find a list of books, some recent, some old, that I would suggest. And if you want to get started with one, read John Hersey's Hiroshima, a brief book. It was the entire issue of a New Yorker in 1946. It's about 30,000 words. It tells the story of 6 survivors in a very factual way, documenting their experience, their horror, interviewed shortly after the bombing. He began his work about 7 or 8 months after the bombing. So there's more. At the 80th anniversary, the books are just pouring out. And some of them are really good, and take a look. So again, thanks so much for the opportunity to come, and remember the message from the survivors. Thank you.
Thank you so much for that really important and powerful talk. I agree, the book Hiroshima I read a year ago and was a really powerful book to read. Want to open up to questions for anybody either in the audience or online. And while people, oh.
Yeah, thanks very much. You know, we don't really hear as much about atomic threat and atomic risk and outcomes as you might imagine. And as we did earlier, it's kind of faded into the background, not for you, but you know, for most people. I was just curious in the numbers of cancers, why do you think that CNS tumors were so prominent when you might think that other more rapidly turning over cells might be?
Yeah, I'll give one answer, and I'm not sure it's satisfactory. I mean, it could be, I mean, this is a group of tumors for which radiation is actually one of the few identified risk factors, isn't it? And perhaps it stands out because the additional boost in risk from radiation can be identified. I mean, that's an epidemiological investigation. There's not a lot of other factors to account for, in fact. So perhaps that's why you correctly point out, see that risk, increment in risk above some others.
Okay, thanks.
And I will say that in terms of remembrance, long ago when some of us, and most people in this room are not old enough to remember, we did have aircraft drills, nuclear war drills, in which the protective thing was to get under your desk. And in fact, I was in California for some early years of elementary school, and that desk had multiple purposes because if there was an earthquake warning, you also got under your desk. So I was putting a lot of faith in that wooden desk to protect me from earthquakes and nuclear war.
Dr. Samet, thank you for this talk. You mentioned some data looking at modeling to estimate effects of the medical radiation. And looks like they are using amount of radiation exposure and using risk based on all data. Is there a consideration of amount of radiation exposure over time, meaning if there is a high amount over a short period versus low amount over a long period, how is that accounted for? Is the relationship linear, or is there some other way they're looking at it?
Yeah, no, a great question. And of course, the atomic bomb survivor experience was essentially instantaneous. I mean, there's some fallout radiation following. There are models, and I'm going to go to the radon experience in a moment, but there are ways to take into account exposure rate, age and exposure, as you saw in one of the figures I showed, and some of the other time modifiers. In fact, in the case of the uranium mining experience, exposures occur over time. So if a man was, they were principally men, was underground for 10 years, there was this exposure, that exposure, this exposure. And in the models that we developed, these are highly time dependent, highly exposure window dependent. And we did those originally in the Beer 4 report, which was 1986, roughly 87. Then we redid that in the Beer 6 report, which involved 11 cohorts. Again, with these fairly sophisticated models, we actually have a global pooling group of uranium miner cohorts, and we're doing exactly that same sort of analysis. So these analyses are pretty sophisticated and have multiple time dependencies built into them.
Thanks for a great talk, John. Lots of thoughts that your talk triggered. One, I think, is just, and I'd be interested in you reflecting on this, the sort of transience of collective memory. That it's so we're in a moment now where people have forgotten what it was like to not have vaccines, and we're less concerned about that. It seems like we're going through a period where a similar thing is happening with nuclear threat. So whereas we had, you know, a couple of generations of leaders who seem to be very concerned about using nuclear weapons, we're now seeing a period of proliferation and leadership who are at least willing to kind of rattle that saber. It also, I think, with the sort of threat of climate change, I think fears around domestic production for power seems to be less, and as well as this notion of having more smaller reactors. And so I'm curious as to like what your thoughts are relative to that.
Yeah, I mean, fortunately, we only have 2 places that have been bombed. And I agree, this is quite remote. So many things are so remote. I mean, that people have forgotten them, they haven't experienced them, they haven't been sort of their currency of memory. And that certainly has spread to many other aspects of public health. I mean, if you're old enough, you remember pre-polio vaccine, which I do. We had limits on things we might do when there were summertime polio outbreaks. And my parents would say, you can't go to the movie theaters, or we're staying away from the public swimming pools. How these lessons get remembered, particularly in the face of today's environment of misinformation and disinformation, I think is really, really challenging. And then some aspects of risk have become so politicized. I'll mention this linear no threshold approach to risk estimation. If you look at an executive order related to the Nuclear Regulatory Commission, it says they should abandon that. So, which, you know, again, implies that we're going to perhaps say that radiation is not as risky as we used to, and then support the development of this, you know, new generation of smaller nuclear reactors that may be coming. I think we underestimate some of these risks. So for those who say nuclear power is safe, there have actually been 5 major nuclear reactor disasters, starting with the one in Russia in 1957 in the Urals Tetra River, which is a place that was blighted by the explosion of the reactor. Of course, 3 Mile Island, Chernobyl, Sellafield in the UK, and then Fukushima. So, you know, again, I think if you look at the number of 5 reactor accidents in this many reactors, I worry. So I agree with your point. And then what we do and how we get our leaders to remember this. Our current president, maybe he never got under his desk, but he should remember what was going on. Saturday morning, you know, the interruption for the public warnings, the nuclear mushroom cloud going up, saying, if this were not a drill, get under your desk. I don't know. I didn't have a desk at home.
Any questions online? No. I have one final question. I think it's striking to me how many the survivors are involved in these studies? And you mentioned some of the, kind of ethical and legal implications, especially I think with the partnership of the US being involved in these studies. Were there any major missteps in the beginning of that, or challenges with working with the offspring cohort who are kind of further away from that time?
Yeah, I mean, particularly in the ABCC days, there were a lot of missteps and a lot of, I would call, sort of imperialistic science on the part of the US. One of the books I put on the list is Suffering Made Real by Susan Lindy, that goes into a lot of this. What I will say is I think that the leadership has become increasingly aware, understanding, and doing better on interactions with the survivors. And I think I've been around the foundation for a long time, but I think going back at least to the last couple of waves of directors, there's one from the US and one from Japan, principally chair and vice chair. They've worked very hard to build relationships with the survivors, and they are watched very carefully by the press and the survivor organizations, as they should be. But I think there's improvement. But the ABCC's bad reputation took a while, and perhaps is still something that is being that still reaches to the current activities of RERF.
Well, thank you
Great,
again
thank
for
you.
coming to deliver remarks.